Okay, 10.3 ellipse. It's the second of the conic sections that we're going to study. What we have is a definition of an ellipse. An ellipse is a set of all points in a plane, the sum of whose distances from two fixed points, called foci, is constant. I know it seems a bit much for a definition, but it's not much different than if you think about a circle. A circle represents the set of all points that are a fixed distance from a single point, which we call the center, right? Now we're talking about 2 points. So the sum of whose distances from two fixed points, foci. One of them will be called a focus point. Very specific because there's an application that we'll talk about called an ellipsoid. It's actually used in medicine. If you ever have a kidney stone, they may use this on you. Okay. The property of an ellipse is that if you take the focus and you shoot something out of that focus, light, electric shock is what they do here, it'll hit the sides of the ellipse and go back through the other focus every time. Okay, it's a really, really interesting property. Let's get into the graph, and I'll be able to describe that reflection a little bit better. We'll talk about all the different parts of the ellipse. Now, there are two different types of ellipse that we're going to study because an ellipse has a longer side. Is everybody done with the definition? An ellipse can be stretched, like taking a circle and stretching out one of the sides. It can be stretched horizontally, or it can be stretched vertically. Okay, that's probably the best way to think of an ellipse. A circle that's been stretched. The first that we'll talk about, we're going to stretch horizontally. Now, an ellipse has a center, just like a circle does. Kind of bear with me here. My freehand drawing's not probably as good as it could be. But that's basically what an ellipse looks like. We took a circle and stretched this one horizontally. That's one way of drawing an ellipse. Now we have a bunch of different points on here. The center, which we're still going to call HK. In this case, that would be 0, 0. We're actually putting it at the origin. But it could be anywhere. All right? The longer axis, we will call the major axis. In this case, it is x. But the major axis length is very specific. It's 2 times a. So if the entire length is 2a, then half of that would just be a. So the distance from the center out to a vertex on the major axis is a, which makes our major axis vertices, in this case, A0 and negative A0, or plus or minus A0. Now that's going to change whenever that center changes. Okay, I have it at the origin right now, so I'm using 0. Then we have what's called the minor axis length. That's 2b. That's this distance from top to bottom, the major axis length. So half of that would be b. So since it's on the vertical, it's going to be 0 0, B, and 0, negative B. So our minor axis vertices is going to be 0 plus or minus B. Again, that's centered at the origin. Once we move it away from the origin, it's still going to be the same concept. We're just going to have to focus more on the center and add and subtract from the center. So we have the center, major axis length, major axis vertices, minor axis length, minor axis vertices. We need to talk about those two fixed points called the foci. The foci are always on the major axis, and they are on the inside of the ellipse. So, foci. That would be a focus. And here's another focus. Now, those are labeled with C. So, in this case, it will be negative C0 and C0. So the focus points, or foci, are plus or minus C0. So all of those are very important.
Are the focus points where it would make a circle?
What's that?
Are the focus points where it would make a circle?
No.
Electric?
No, that's not how that works. There is a relationship that connects A, B, and C. That relationship is C squared equals A squared minus B squared. That is very important. That connects A, B, and C. So it's not that it's a circle. Okay? And let's talk about that reflective property that I was telling you about earlier. An ellipse has the reflective property that if you put something at the one focus, that could be a spark plug, it could be a light bulb, anything. It could be someone talking. Okay, I've seen an auditorium that has an ellipse ceiling so that people in the back can hear just as well as people in the front. Okay, because it redirects all the voice that someone's speaking in the front to the back of the room. So, whatever this is, the application in the book is called an ellipsoid. They actually put a spark plug there, and they shock. They put out a shock wave. And that wave will hit the side of the ellipse, or ellipsoid. And no matter where it goes, no matter where that shock goes, it will always reflect through the other focus. So that's where I was talking about that kidney stone. So let's say this was, and this is kind of a rough sketch, let's say this is your kidney. Not looking too good on screen. All right? Which is inside your body. That's your body. You can put this machine against the body and actually disintegrate a kidney stone, okay, without ever having to cut somebody open, which is really, really amazing that they can do that. Okay, I have a video on it that I could show you, but it's the very first thing in our book if you want to read about it. Okay, it says medical technology, but the ellipsoid is used to break up kidney stones. Electric shock. They hit this kidney stone with that shock. They'll probably hit it 2,500 times. And eventually, you hit something enough, it will disintegrate. And the stone will disintegrate into small enough pieces that you can then get rid of it. Okay, so that's the one. That's the horizontal major axis. So the major axis in this case would have been the x-axis. What's the equation? We did all of that drawing. We don't even have an equation. The equation of that is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. That's the equation for an ellipse. That's major axis length is horizontal. The longer side is the horizontal. Are you ready for the vertical? Stretch it vertically. Pretty much all the same information, we're just going to switch them around.
Is it a different equation?
Slightly. Very, very small change.
So it's horizontal.
That was the horizontal. Yeah, you can see that it's longer horizontally, right? This next one. I'll try to make this very distinct. Does that one look like it's been stretched vertically? Okay. Minor axis length is, the major axis length has changed. It's now vertically. Okay. A always goes with the major axis. So my vertex is going to be 0A and 0 negative A. I'm centered at the origin, but we'll call it HK. My minor is B, so in this case, it's B0 and negative B0. And the foci will change because the foci always go on the major axis. 0C, 0 negative C. Major axis length does not change, still 2A. Minor axis length does not change, still 2B. Major axis vertices, though, are going to be 0 plus or minus A. That changed. You go back and look at the last one. They were plus or minus A 0. Now they're 0 plus or minus A. Minor axis vertices plus or minus B0, which is the opposite of the last one. Foci, 0 plus or minus C. Again, opposite of the last one. Okay, what else? Foci, vertices, major minor axis lengths don't change. The center does not change. It's still HK. Does the relationship between A, B, and C change? No. We're still going to use C squared equals A squared minus B squared. Okay? The equation changes ever so slightly. X minus H squared over Y minus K squared over. Now, the major axis always has A involved. Which is the major axis in this case? The vertical, the Y. So we're going to put A underneath, or A squared underneath the Y minus K, and B squared under the X minus H squared. So what changed? You switch to A and B. That's it. Switch A and B. It's not really that big of a difference. Any questions on those two? So you got the idea of what an ellipse is, all its different parts. I want to do 2 examples, and then we'll call it a day. All right? Everybody ready for them? Anybody not ready? Right. The equation for the given ellipse and then find its foci. Let me give you a picture. Okay, the center of the ellipse is 2, -4. Okay, that's the center. I'm going to give you 2 of the vertices. Eight, -4. 2, -7. This is your center. This is the vertice, and this is the vertice. Basically, I'm giving you that much of the ellipse. Can we draw the rest? What do we need to know? The other 2 vertices, right? The vertice is at 8, -4. If I go to the opposite side of that, I want to call it a reflection, or I want to say it's the same distance away, what would that distance be? 6. It's a length of 6, right? So if we subtract 6 to the left, we'll have our other vertice, right? So I subtract 6 from the 2 or the -4? From the 2. 2 minus 6 is -4. So -4, -4 is my other major or minor? Major vertice. What's the other minor vertice? Looks like to me, this distance is 1, 2, 3, 4. Wait, did I do 3 or 4? I think I drew it wrong. I put 2, -7, but I think I put 1 too many lines in there. Let me redraw that. 1, 2. Spread that out. That was a really bad drawing. All right, 2, -7. All right. So how many do we actually move? 3. So we're going to go up 3. And that's going to be what point? 2, -1. Excellent. Now you can add this in. I'm just kind of putting a grid in there. That's our major axis. This would be our minor axis. Since we're not centered at the origin anymore, I hope that looks a lot better on your graph paper, because that looks terrible up here. That looks like a really bad eyeball. All right. What's the equation? We need to find A, we need to find B. Major axis length is 2A. The minor axis length is 2B. So what's A and what's B? We actually already said what they were, whether you realized it or not. The major axis length is 12. Half of that would be 6, because we need 2a. So 12 equals 2a. A is going to be 6. So whole major axis length is 6. Half that is. So we got A, we got B. We can put an equation down. X minus h squared over plus y minus k squared over equals 1. Which one gets the A? Which one gets the B?
But if you said the A, 12.
12. The entire distance, do a different color, from here to here is 12. And then the entire distance this way is 6. So the major axis length was 12. The minor axis length was 6. So that's why I said 12 is 2a, 6 is 2b, a is 6, b is 3. Okay, so the a squared goes under x, or h, however you want to say it. X is probably a little better, the whole horizontal, right? So, x minus 2 squared over, which is 36, plus y plus 4 over 3 squared, which is 9. There's our equation. That wasn't too bad, was it? You don't solve it. That's the equation. That's what represents all the points that we just drew, the ellipse. There's an x and there's a y. What we do need to find is C. Because we need the foci, right? A squared is 36, B squared is 9, so C squared equals 27. Right? So C equals plus or minus the square root of 27. All right, so my foci are going to be located on the major axis. So I'm going to go square root of 27 left and right of the center. Ready? 2 plus or minus the square root of 27, comma, negative 4. Do you follow me on that? Now, let's go ahead and put that into a decimal so we know exactly what that would be, where we would plot those points. Okay, I already have them up there. So, we're going to get, out of this, 2 points. 7.196 negative 4 and negative 3.196 negative 4. Okay, 2 plus the square root of 27 is 7.196 approximately, and 2 minus the square root of 27 is negative 3.196 approximately. So, about here, and about right there. Questions? So far, so good? Okay. I have one more example. You ready for it? This one will be a little bit easier. There I gave you the graph. Here I'm going to give you the equation. Find all of parts of x plus 4 squared over 9 plus y minus 3 squared over 25. All right, we need to determine immediately what's a squared and what's b squared. A squared is always the bigger number, in this case 25. So a equals plus or minus 5. B squared is 9, so b equals plus or minus 3. What's the center? Negative 4, 3. Okay, so a combination of the center and A and B, we should be able to get the vertices. Negative 4, 3. Now, which is going to be the major axis? The y. So I'm going to go up and down 5 from the center. 1, 2, 3, 4, 5. What point will that be? Negative 4, 8. Good. Add 5. Subtract 5 to go down. 1, 2, 3, 4, 5. So it's going to be negative 4, negative 2. Now, the minor, I'm going to add subtract 3 to the x. Negative 1, 3. Negative 7, 3. So let's label these. Major axis vertices. We have negative 4, 8 and negative 4, negative 2. The minor axis vertices. Negative 7, 3, negative 1, 3. We got the center, major vertices, minor vertices. What's left? Both sides. C squared equals a squared minus b squared. C squared equals, what was a squared again? 25. B squared is 9, so c squared equals 16. C equals plus or minus 4. From where? From the center. Up, down, left, right. Up and down. So I'm going to add, subtract 4 to the center. So up would be what? Right on that A. Negative 4, 7. And down? That's correct. Negative 4, negative 1. So the foci, you want to do it this way, would be negative 4, 3 plus or minus 4. That's another way of writing it, because we're adding to the y, which gets us negative 4, 7, and negative 4, negative 1. So we have foci, major axis vertices, minor axis vertices, the center. I don't think there's much else you can do with that. I think we found everything. And we graphed it along the way. Okay, are there any questions at this point in time?